this panel, is the last thing today. So well done for all of you for seeing it through. And as it's called a summit, we're trying to finish on a peak as well. And I've been really excited about running this panel just because of the brilliant and diverse set of minds that are on it. So if you've been storing up any questions through the day, something hasn't been answered, some fundamental challenge or promising avenue, this is the group of minds to ask it to. And we'll do the same format as before. I will introduce everybody one by one. They will then reintroduce themselves and give a point that they think is a challenge or an open problem for the field, as well as a promising avenue. Okay. So it is my pleasure to introduce on my right Professor Azalia Mirhoseini. Azalia is a professor in computer science at Stanford and does research on developing capable, reliable, and efficient AI systems for solving high-impact world problems. So again, like Sergey's talk, I think that's exactly in the core theme of the summit. She's been interested in scalable deep learning optimization and the interface between programming memory and software and hardware, and spends time at Google DeepMind and was formerly at Anthropic for what she told me last night was her gap year before going on to the faculty at Stanford. And so it's a pleasure to have you with us, Azalia. We have Surya Ganguli. So Professor Surya Ganguli is at Stanford in applied physics, where he leads the neurodynamics and computation lab. Surya is, is someone that has a really deep sense of the theory in a field. And so coming from theoretical physics, neuroscience, and AI, he's able to lend this deep mathematical understanding to thinking about the emergent computations that are going on in neural systems like the brain and in other intelligent systems. Surya was at Google AI and Meta AI and has become a venture partner on the Byron Health team at A16Z. We have next in line, we have Eliza Kosoy. So Eliza is graduating from UC Berkeley and going on to work at Google at the AI UX learning group. So Eliza and I met in St. Andrews at a summer institute called Diverse Intelligence's Summer Institute, that if you haven't heard of or been to, I highly recommend. You get to spend like a month in St. Andrews in the summer discussing these sorts of ideas. Eliza works with Alison Gopnik and has been doing research related to the way children learn to interact with the world and acquire systems of understanding. And in particular, more recently, has been thinking about how to create benchmarks for evaluating machine learning models using concepts from this kind of cognitive developmental literature. She also founded a company called Eliza Dolls. It's extremely interesting, and I encourage you all to check it out. That's sort of the motivating problem is how to kind of inspire young girls to learn these technical concepts like programming. And finally, I guess the far left for you, it's a pleasure to introduce Gayatri Sarkar. So Gayatri is the owner of Adavita Capital, which is one of the few female POC-owned funds in the world. So I think that's worth a round of applause in itself. Adavita and Gayatri invest in generative AI, deep tech, and in general, advancing the human race. Formerly, Gayatri was a Federal Reserve bank manager and started her career as a data architect at HP, IBM, and Goldman Sachs. Recently named as Crown Patron for the Princess Grace Foundation from Monaco, which I believe is a foundation that looks to encourage aspiring young women in the arts. In living memory of Princess Grace Kelly. So this is just a fantastic collection of minds. We've got a lot of different backgrounds and ways of understanding, AI, what the fundamental challenges are. I think we'll go back through in that order, and if everyone could, introduce themselves, maybe say anything that I forgot or they think is particularly important, and then give what they think is a fundamental challenge and perhaps a promising avenue for solving it, and then we'll go into a discussion format. So Azalia, if you could.
Yeah, so thank you for the very kind introduction. I can start with talking about challenges of AI, and there are several challenges in terms of AI development. But one of the challenges that I am particularly interested in is the way that we can scale verification of AI models' outputs. And should I elaborate more, or we're going to discuss more?
I can bring the conversation back to that
Okay.
later, but yeah, no, the evaluation methods for AI, how can we scale those? We were talking a bit about it at dinner last night, and certainly we'll come back to that. Yep. Okay. Surya?
Yeah, thanks again for the intro. I think if you think about order of magnitude discrepancies between AI and biological systems, I think there's three that really stand out. One is data hungriness. GPT-3, if it read at the same rate that humans read, it would read for like 20,000 years. Two is robustness. These systems suffer from crazy adversarial examples that we do not suffer from. Their illusions are not ours. And I think those two things are really deeply intertwined. Together, they suggest that they give me an uneasy feeling that maybe everything we're doing is wrong. These things just don't think the way that we do. They're not robust. They're way more data hungry. And I think those are key challenges. And being able to solve them might help with planning and reasoning and so forth. The third is energy inefficiency. But that we made a big mistake when we went to digital technology and never figured out analog technology. That's going to be harder to solve.
Eliza?
Okay. Tough act to follow. I just wanted to make one correction to my introduction. I don't actually know where I'll be working when I graduate, but I am looking if anyone's hiring. Okay. But something that I think is a challenge within the AI space that I've seen lately is that nobody wants to talk about how children are using AI. So I've been doing a lot of studies where basically plop kids in front of a computer and watch them use GPT and DALL-E and try to categorize what they're doing. But then when I try to submit this places or try to talk to companies, everyone is terrified about even talking about this or admitting that children are using these large language models. And I think that's really interesting. And I'm really curious to see, kids are growing up with this and they're going to be the main users. So what does that mean? How is it affecting them? I personally think it's kind of a cool thing for kids. So that's what I'm curious about.
Excellent. Thank you. And Gayatri?
Yeah, I think, can you hear me?
Yeah.
Yeah, okay. So I think,
The mic is not on.
okay, no problem. I'll use this. Okay, hello? Good. Okay, so when Ru said that we have to ask a question which is supposed to be a fundamental AI challenge, I remember the Hitchhiker's Galaxy is like, you have to ask the right question in order to get the answer. Now, I had a certain perception towards asking the question. Then I spoke with Felix, and we were like, this is a main problem as a VC, and we are a growth stage venture capital fund. We write checks from 10 to 50 to 100 million plus. From Series C onwards, the barrier to entry in order to do a startup, when you are planning to launch a startup a long time ago, it was like you have the cost of server, hiring, computational power, and all those things. And now, starting even before generative AI, if you want to do something else also, even now, it's like for $1,000, you can have your own startup. But when it comes to generative AI, the cost of barrier to entry is very, very high. And when we ask the different questions, whether, as Surya said, whether the traditional energy sources for data centers and compute the production at scale of intelligence, and it matters not just single industry, for all the industry, and also for all countries. And similarly, there's no limit how much incremental human intelligence that we want to create or we want to buy, hence the supply and demand. And we are back to the question, in order to pursue all this act, there are amazing scientists that are out there, but we need billions and billions of dollars. So we went from early stage VCs who are writing checks, smaller checks, so 10K, 100K, or $1 million is not a factor. You're starting with 5 or 10 million when you're buying 100 plus of GPUs, like looking at Inflection having 22,000 H100s and Stability AI having so much of H100 and still failed or fell from grace. So the question is that how do we navigate this space in order to make sure it's still competitive and it's not the law of large numbers, because the MANG, which is like, Meta, Amazon, Apple, now NVIDIA and Google are playing in this field, and we want more competition in this space to have more scientists innovate. Yeah.
Great, thank you. So I'm hearing two kind of classes of questions or challenges, and they line up with a lot of what's examined in generative AI. On one hand, there's questions about training. Okay, there's questions about fundamental questions about training, the amount of data required, and then there's more of these kind of organizational questions, like, as Gayatri pointed out, very few universities even can train very large models. And then we have these questions of evaluation. Okay, given the model has been trained, how do we evaluate generative AI to make sure that it can perform at human or even superhuman levels on the range of tasks that we want it to? So I think we'll start with the evaluation question, because Azalia said it first. If you wouldn't mind talking through a little bit what you mean, and see what some of the others think about it.
Yeah, so as the models are becoming more and more capable, the type of problems that they're starting to solve, the types of problems they're solving are becoming more and more complex. And so far, the practice has been that we collect tons of human feedback for kind of like fine-tuning these models and kind of steer them to generate more sensible outputs. And what I mean by that is we are basically asking human to judge the output of the generated samples and decide which one is better than the other. And this is kind of like an easier task when we are asking about whether this is a factual statement or whether this is a harmful statement and such. Those are relatively easier kind of topics to judge. But as the models are becoming more and more capable, then now they're solving complex like coding problems or math problems or very complicated engineering tasks. And a lot of these kind of more complex problems are what are going to bring a whole lot of value that at the end of the day are going to justify the huge amount of cost that goes into training these models. So then a challenge becomes, how do we judge the output and how we kind of make sure that these models are kind of have the ability to improve themselves and keep getting better and better. Because now collecting human feedback becomes harder, because some of these, like maybe human can solve themselves, right? Asking for their help is kind of like becomes harder and harder. So I think there's going to be a lot of like interesting research and work that goes into coming up with automated ways, using AI in the loop and using tools in the loop to kind of verify and the output or the goodness and correctness of the outputs of the LLM models, and use that to kind of like have this self-improving feedback loop such that the models become better. There's a term that some people use for this. It's called scalable supervision. So the idea is if the models become so much better than us, maybe we can't like alone like as human supervise them. So the supervision process should be heavily have AI in the loop and should scale with the capabilities of the models.
Yeah, that really seems like a fundamental challenge. I wonder, Eliza, so a parent does this, right, to a kid, is often the kid will develop a mathematical ability far beyond the parent, but the parent is responsible for coaching them through it. Any thoughts from development?
Yes, definitely. It's great that you brought that up. We have a paper that came out, I think, last year, where on a philosophical level, the question is really like, how do you compute the age of a large language model? But on a deeper level, what we do is we take core developmental experiments that come from different ages. So for example, a child learning object permanence as a baby, or theory of mind, or causal reasoning, all these things that that happen to us as humans, and then we turn those into just text and experiments and put them into a large language model and try to evaluate as best as we can as humans how it does on those. And it's been so interesting because unlike our developmental trajectory, large language models have an insane one. You know, like they're 8 years old, but they're not 16 years old, but they're not 3 months old, and they're really not good at like object permanence, and they're okay at theory of mind and things like this. So I think it's a really interesting question, and it's hard to know how to really evaluate it, but I've been really inspired by developmental literature, because if you think about it, like there's all these experiments in developmental psychology that probe babies and things. Well, we're not probing babies, but you know, like really like trying to understand how babies are thinking about things. And you can't ask a 6-month-old anything, right? But you can do experiments and get outcomes out of that. And I think large language models in a way are kind of like this black box baby that really is trying to tell you something, but you don't know how, like you can kind of take it for granted. So I think there's a nice analogy there between using experiments like that to try to probe at these models, and yeah.
That's very interesting. So could you imagine a situation where, you know, the existing language models you have are some kind of building blocks in a larger automated evaluation framework? How would that sort of pipeline of evaluation on superhuman tasks, and many of them, how could that be built? What would that look like?
When I was at Anthropic, we published this paper called Constitutional AI, where the idea was
Great paper.
the idea was maybe one way to kind of like supervise the model, have the model supervise themselves, is like to kind of guide them through a set of principles. And in that case, the principles were, in that particular paper, was about how to ensure the models are generate harmless outputs. So the principles were actually taken from the UN human rights set of principles. So they're like a set of like dozens of principles that each is very short, and they're kind of like common sense stuff for us humans. And then the model is asked to follow this constitution basically by a series of like questioning, like the model should revise itself in an iterative loop by answering this question of whether it's following this constitution or not. And if it doesn't, then it has to regenerate the output in a way that it does. And it's kind of interesting to see that the model, even though you would think if it knows already a lot of these principles are already going into the training of the model, but it's like if you make it like kind of crystal clear in a constitution, then it can actually follow that and improve its kind of correctness or harmlessness in this case a lot more. So there are ways to kind of integrate, kind of use the model as an orchestrator or a follower of certain rules and principles that we know the model should follow. And this could change for a programming task. Maybe there are unit tests that the code should pass and things like that. So there are a lot of ways to bring in the knowledge that we already use as human to judge whether we are outputting, whether the models are outputting correct information or not. But at the same time, this is still very early in this, and a lot more work is needed. And things get harder and harder as the models become more capable. Yeah.
And I'm sure we're going to learn more and more during that process. Yeah, so as a cognitive scientist, I really like this idea of using abstract knowledge about what the form of a correct solution would look like, and then not necessarily having to do the computation oneself. And bringing in those kind of ethical constitutional principles, yeah, that sounds fascinating. Okay, so well, maybe let's move to the training aspect. And so Surya, you said, you know, that sounds like the most fundamental challenge. Maybe we got it all wrong right from the start when we built the transistor, but more generally, the kind of current focus on this class of learning algorithms that are data hungry, et cetera. Would you care to elaborate a little bit on that and maybe offer a kind of where we should go from here? Yeah.
Yeah, I think an analogy that that I've heard is like, let's say we were to teach children how to do math. just by throwing a whole bunch of multiple choice questions at them and just say like, this one, the correct answer is A, this one, the correct answer is B, and so forth, right? And just like, we threw like millions and millions of things at them. Maybe they would learn, but maybe they wouldn't, right? And so we have a beautiful system of curricula that we give to students. We teach them intermediate concepts. Like, you know, I'm teaching my 8-year-old math at the moment, and it's super fun and interesting to see. And I create a model of him, and I figure out what concepts he's missing. Then I give him careful problems tailored to teach him that concept and so forth. And I make it fun for him and all that. So this is what we do as humans to each other to help each other learn. And we're not doing any of that for our large language models. So the proximal pathway could be things like active learning. We've worked on data pruning and taking these scaling laws that are power laws and bending them down to exponentials, at least in some cases. But there's so much work to be done there in terms of, I think, active learning, curriculum learning, LLMs having internal models of the world that they can correct by asking for new examples and so forth. I think the world is wide open there.
Wow, yeah. And that kind of speaks to this approach that you and Jay have of really trying to connect these high-level ways thinking about thinking to the sort of underlying computational system. Thinking about Gayatri, some of the things you brought up there, I know that at the same time, you're trying to invest in these companies that are using these very data-hungry and energy-hungry systems to solve a wide range of interesting problems. And at the same time, you're concerned about the energy resource, and you're trying to invest in energy infrastructure for the future. And so how do you reconcile the two of those?
I think it's tough because we look at the world through our founders' eyes. And we are looking at a generative AI company, then we are looking at a robotics company, a chip designing company. So, a lot comes into the mix. But we try to go as a deep tech investment fund much more focused on what's our thematic investment and where we think it adds value. I'll come to the point on the VC side. As you know, 99% of the startups don't make it to Series A. And then some of them make it to Series C. So when they come at Series C, almost they have built the growth stage solution. But at the same time, there is a different kind of environment that we are living in right now. And I feel like I always tell to my limited partners that we are living in the era of 60s and 70s where the computational power is getting built. But at the same time, we have seen in the dot-com burst and boom, it's like, the 20 search engines did not make it. And then Google came. So we need to make sure as an investor, are we investing in those 20 search engine? At the end of the day, we are always betting on founders. A team, always. B product, it's okay. Because if the team is A, they will always find out what's the opportunity. We invested $60 million plus in Cohere, which is a Canadian company that focuses on sparse data model, which we thought that it was very interesting. And they also have a strong focus towards data privacy, also not a open source model, it's a closed source model, which we thought it was very interesting business model, did not have a nonprofit approach. Also, they focus on tensor processing unit, which reduces carbon footprint. So looking at this aspect, when it is not a number one company like OpenAI, Anthropic, and other, but it is maybe number 3. But at the same time, when we are looking at it as a team product, maybe, B product out there, but the way they have set up the business model, the way they went at it, we were like, okay, this is something very interesting where they're providing almost LLM as a service, and we liked it. So that's one area. And then other areas, like if you look at companies like Anthropic and others who are huge and big, and they're very research focused, and we are trying to understand when we are competing for the number 1 position, how many such companies will exist in the world. At the same time, how much research will be a big factor into making it to the other side. And that's when the computational power comes in effect. How much of energy can you keep on, buying NVIDIA chips? So I personally believe that down the road, lot of AI companies will end up becoming a product feature of a large generative AI platform where people don't have to go and buy data. So many of this, like OpenAI, Anthropic, they have to go and buy data. Also like companies which are also trying to solve problems towards supercomputing and also a better chip designing solution. So I'm talking about something, you need a lot of money, but also a company that has the network in order to build this. It will take time. We don't know who's the winner, but again, we are betting on the future. At the same time, we are also trying to learn, because this is a very new area of research. Even the research scientists are trying to understand, and we as a VC, we're supposed to think ahead. So it's a tough solution, but at the same time, we are thinking this is an ecosystem that is getting created, like the future of iRobo or Her or something like that. And a lot of VCs are using the word like cognitive as a service, like how close you can be with human intelligence. But at the same time, I want to ask question, like there's so many amazing companies that are built and so much of research being done, but how much that can be utilized for a proper scalable solution. You can build, like the biggest example is like, and I think a lot of VCs talk about it, like the perception of what you're building, like nuclear fusion, nuclear fission. Like, if this was built today, people are like, oh my God, this is game changer. But because this was done before and there was such a repercussion, like for us, the discourse is completely, completely different. So as an investor, we want to understand and ask the right question to make sure that the founders bring the kind of answers that are scalable, but also the customers wanted, and you can build the solution from ground up. So, we don't know. I mean, we can bet on a great team, on a great founder. That's all I can say.
Okay, yeah, and testament to that sort of idea of multiplicity of minds and the human factor. So speaking of efficiency, right, Surya, the human brain, extremely efficient, in contrast perhaps to current language modeling technology, and you mentioned synaptic pruning. Do you think there are a set of kind of candidates that could be integrated into the current pipeline based on neuroscience to make it more efficient?
Yeah, I think, so there's several notions of efficiency, like data efficiency, energy efficiency, and so forth. I think on the energy efficiency side, the brain is remarkable. It's 20 watts, right? Which is, we're literally dimmer than the old light bulbs. I mean, and so how does it do that? Like, where did we go wrong, right? We're relying on very fast and accurate bit flips. So we're moving tons of charges around many, many times a second. Every fast, reliable bit flip by the laws of thermodynamics demand energy expenditure. Biology is completely different. It's slow, noisy, and almost out of control. Every intermediate step is really noisy, but the final answer is just good enough, and that's the secret of its energy efficiency. Like if you think about like how much energy, electrostatic energy is in a single spike, it's a minuscule amount. It's just above the energy of thermal jiggles, right? So we're not going to be able to solve the energy efficiency problem by sticking with digital technology. That's the bad news. The good news is it allows room for open-ended thinking about analog or mixed analog digital computation. My colleague Kwabena Bohannon at Stanford has some very interesting ideas on nanodendrites and so forth, and building 3D transistors and various things like that. So I think that's a really exciting area of research. It's a tough area of research. It's well suited to academia because I think companies like the ones you're investing in, they don't have the long horizon to be able to do that. So yeah, I think that's a very interesting direction to go. It's near and dear to my heart also because I think about energy accuracy and speed theoretically in various computations. And there's very beautiful theory to be done there as well.
Wonderful. I think, Azalia, I'd like to ask the same question of you, maybe in a slightly different way, because what I think is so impressive about your career and your research is you've been involved with training these big models all the way down, even to the engineering that's involved with manipulating the data that they're trained on. And I wondered if you had any thoughts on the efficiency problem, however construed, and maybe even whether from some of your colleagues at Stanford you've had ideas in common about how to introduce ideas from biology, or whether that's not quite the right time to think about it.
I think it's always the right time to think about biology, and there are a lot of learnings that can be transferred. I haven't been focusing on that area, but I kind of I have been thinking about scaling, because that's probably the best kind of research focus right now, how you scale things. It's going to address a lot of these challenges with sample inefficiency, the huge upfront cost. So while it's super exciting to do foundational research on new ways of computing, I think we still can do a whole lot with our current models to bring efficiency to them. I think I worked on the mixture of expert for deep learning and LLMs, and that's a small one way to bring efficiency, getting inspired by ideas that we had in computer architecture and systems on block sparsity and dynamic routing into the model design. But also thinking about the future, the way I envision models is we're gonna go farther away from one giant model that just processes all the data, and we're gonna have more and more mixture of models that work together. We're gonna have specialized models and larger general natural language understanding models that work together, because again, it does not make sense to spend the same amount of compute on every token of data as we do today. Different data points require have different amount of knowledge and information in them, and we should leverage them to process them in different ways, assign less or more compute to them. And I think these mixture models in the future are going to be one way to approach this dynamic compute.
Yeah, well, it's sort of, at least at first, slightly intuitive. By growing the number of parameters, by growing the number of experts, you can actually get sparser, more efficient computation. I think that's been a great kind of learning part of this journey of scaling. Okay, so maybe just a last topic that I've been particularly interested in, but I think is at the edge of everyone's questionings and inspiration is creativity. Whether that be adding a new expert for something that you've never seen before, or adding an evaluative method for something like human creativity. So I wanted to go first to Eliza to think about, children extremely creative, humans extremely creative, and creative in creative ways. Do you see any promise in some machine learning avenues, or do we need to go back to fundamentals?
That's a good question. It's funny, as I was saying, the study I'm doing where kids use GPT and DALL-E, I think the modality really matters. So what I'm seeing is when kids are using GPT, I think they just think it's like a Google and it's like a search engine, and they're just reaffirming their own knowledge base. But with DALL-E, which just does the image generation, the kids pop off. I mean, they are looking and searching for things that clearly they don't have access to in their world, and are very imaginative, and I think don't exist in the world. And when I categorize these things, they're really searching, they're being super creative, in my opinion, and the things that they are clearly seeking, they have thought about but had no way to almost formalize. Maybe they could have drawn it or something or imagined it, but this gives them this crazy way of seeing it, which I think is going to be a really cool creative outlet. I was just talking to the guy that made Sora, and I was like, let me put some kids into this, and they're not ready for that. But, I think that these are going to be really exciting ways for humans to be more creative, and I don't know, I'm excited for that. And has anyone here used it for that? I think that, especially the multimodality, is going to be really interesting. And I think it's going to be a great creative tool, and I'm curious to see what comes
Inject some kids in the mix.
Yeah, and I think definitely looking at what kids are doing is interesting versus adults. I think adults tend to be less quote unquote creative when they're using DALL-E, which I don't know, that says a lot about us. I don't know what happens to us as we get older, but they're seeking, when they're using DALL-E, they tend to look for things that already exist in the world and that they have access to versus the kids. So I don't know. Yeah. Hopefully it prompts us to do more creative things.
Yeah,
somehow.
excellent.
Yeah.
Surya, in like creative scientific problem solving, you've gone through these different fields from a theoretical background and beginning to apply that theory to these more empirical realms like neuroscience. How might we go about designing an autonomous agent that has that kind of creativity?
Yeah, I mean, there's several groups trying to work on AI scientists, which I think is quite interesting, right? Trying to make a much more rapid feedback loop between theory and experiment, right? Where the AI suggests the next experiment, robots do the experiment, say in chemistry or something like that, and then they update the AI hypothesis space and so forth. I think that's pretty exciting. I think it's a bit of a longer time horizon, maybe 5-10 years to get something sort of economically interesting. But on the creativity side, I'm really blown away by the creativity of LLMs, especially in mixing style and content and text. Like, I get a big kick out of asking it to explain scientific context to me in the style of different types of poetry. And it's just remarkable, right? So like if you think about style transfer in the image domain, we actually understand that pretty well. We understand how you can take a photo and convert it to a Picasso. Like the style of an image can be succinctly described by certain correlation functions in the deep layers of a CNN, right? That's simple. But how do you quantify the style of a poet? It must be hiding there somewhere in some kind of function in the latent space of an LLM. How do we understand that? I think that's a type of theory project that's ripe for analysis, I think, at the moment. I've actually discussed with my students how we might do that and stuff. But that combination of combining content and style is just incredible.
Can I ask what the last thing you searched and which poet it was?
So I asked it, I've done various things, but I asked it to explain the works of Einstein in the style of Shakespeare. And it gave me a beautiful poem about like the starry skies and the curvature of space and time. It was I tweeted about it, so if you search my tweets, you'll find the entire poem.
The sun rises in the east and bends light around it.
He was even better than that. Like I couldn't come up. I'm not a poet by any means. Like, but I can't come up with this stuff. Actually, the funny thing is the way I learned about GPT-4 is I was having a dinner with a friend of mine, Sal Khan of Khan Academy. We're all getting together with a group of friends, and then we had a great dinner, and then we left, and then Sal had access to GPT-4 before the world did, and he just sent us a poem like about half an hour after dinner. And Sal's a pretty creative guy. Like, I was really impressed. Like, that was an awesome poem. And then months later, I learned he just created it with GPT-4. You know, like, so my first encounter with GPT-4, unbeknownst to me, was a poem. You know, it was interesting.
Azalia, could we use eval methods to push these models to be more creative, or training?
I think as the models, I think the models are just going to be more and more creative as we go forward, because they are able to search a much larger search space of like planning and optimization than us human can do. So, and they can, as they become more efficient in like sampling that space, it's just like more and more likely that they come up with more creative kind of solutions. My kind of experience with them, it wasn't particularly in large language models, but I did this work on AI for chip layout optimization, which we were training this RL agent to kind of design different layouts. And it was so interesting because we were not kind of giving them the same kind of constraints or rules of thumb than a physical like design engineer follows that to kind of simplify the space to kind of come up with optimized layouts. We just give them the end objective. And just by being able to search this space more effectively, they could come up with like various kind of shapes of layout placement and optimization that was unintuitive to a human expert, but they were yielding better end-to-end results. Wow. So I think that's like, I don't know if we call it creativity, it's just that they can search a larger space and come up with more other optimization and solutions that maybe didn't exist before. So.
Thank you. Yeah, to search outside the constraints of human learning. So I thought maybe we'd take one or two questions from the crowd. Does anyone have a question for any of the panelists or a point that they think is interesting that someone might answer to? So raise your hand, yeah, and can we have a microphone over there? Thank you.
Thank you. I have a question for Azalia. I know you mentioned that the future is going to move more from large general models and more to more specialized models, but I'm also curious on your thoughts on blending models currently.
Sorry, on learning models?
Blending models,
Blend?
if that's...
How to blend models, merging models?
Yeah, so specifically, if they're more effective, if you take bits of, for example, Claude or bits of Mixtral, and you combine exactly what you want. What are your thoughts on that?
I think there are already startups that are trying to kind of route queries and prompts to different backends, which is like very at the surface level. But I think the idea of like merging models is going to be more and more interesting. Like I am particularly interested in like models that can cross-attend to each other, like cross-attending to the attention layer of each other, because these KB caches, for those of you who are more familiar with the language here, KB caches in language models are a new way to index and store information. So it will be very interesting to see how for merging models, we can leverage those new indices that these different models generate and kind of like go from there and extend the capabilities of each model.
KV cache is not so new in neuroscience, old idea there. So one more question. Yeah, Felix. On your left.
Oh, wow. Thanks. Sorry. Yeah, there's actually the KV cache being in neuroscience for a while is actually a good comment that gets into my question, which is, we've talked a lot about these high-level cognitive capacities like creativity, reasoning, planning, difficult to define, difficult to really nail down, thus difficult to evaluate, at least with the traditional setups we have right now. Yet when we try to ideate about what do we do next, there's always these references to developmental psychology, cognitive science, psychology, neuroscience. And yet we have kind of like a lacking of really strong collaborations between the formal mathematicians, physicists, CS folks, and then the developmental psych, cog sci, et cetera. And I was hoping to get to that with the panel, but we didn't quite dive deep into it. So as a cognitive scientist, I really would like to be able to collaborate with more folks on the hardcore side, which is fun. But I'm curious, from the other side, from the physics, the CS, does anyone on the panel see any reason as to why these collaborations don't happen more frequently? Is it a structural issue? Is it a content issue? Is it a language issue? Is there something we can do about that?
Can I answer that?
Please.
We invested in a company called Neuralink, which is literally the combination of everything, from robotics to neural science to everything. And now, when we invested, the idea of having an invasive chip putting into your brain, and even blind people who are born blind can also see, was like a crazy idea. And now we're seeing people can play chess with their minds, and then next is blind people can see. So it's a combination of all. And I think the future is that if we can, and I know there's a lot of optimistic and pessimistic view, but the idea of that is if you cannot fight AI, let the human also be a part of the machine, where you can have a similar computing power. I mean, I'm literally talking about sci-fi, but that's one company that we invested. We felt almost kind of where all these different departments came together to build something interesting.
Yeah, can I respond to that for a second? Maybe just if the conversation could last one more minute. So that's interesting because Neuralink is funded by a massive, really well-respected group of people that can kind of corral all the resources necessary to get the right people under one roof, right? So I'm wondering, given that that's like a low probability event of reoccurring, right? Like the more probable stuff of like in academic contexts or smaller startups, yes, there's something to do aside from just having like a bunch of really well-respected, rich people kind of put a bunch of smart folks under one roof. So like another method we could do as well, like a Neuralink 2.0, but for more of these dev-psych or cog-psych questions, something like this.
Yeah, I feel like actually, I mean, I feel like at Stanford it actually happens a lot where neuroscientists, physicists, computer scientists, psychologists work together. We have a few funding mechanisms to help that. We have a neuroscience institute, we have a human-centered AI institute, we have calls for proposals sometimes where we specifically fund neuro AI, and we explicitly ask people from different fields to work together. So at least from my corner that I'm in, I feel like that's all we do, actually. I mean, we do a lot of that stuff.
And Berkeley too, I feel
and
like
Berkeley as well. And actually a lot of the universities are really getting excited about the neuro AI interface. So I think it's a matter of time. You need people with different perspectives to be able to talk to each other, to be able to want to talk to each other. But I think that's happening, I feel like.
If I may offer a hot tip, Felix, what works for me is I just go to the different floors. Like you just go to the 8th floor where the AI people are, and you'll get a collaboration eventually, you know? So branch out, physically explore. I think that works really well. Yeah.
I'd like to answer your question, Felix, but during my closing remarks, which I think it's about time for. So could we all thank the panelists?